All right, pre-calc guys. We're getting back to this. We're going to start verifying uh, trig identities. We're going to verify these identities. They're going to show us something, and we're going to see if it's true. And what we're going to use today, really for all of this, are just the reciprocal identities. And these you should already know. If you don't know, just keep studying them. Just keep working on them. And these Pythagorean identities. But these Pythagorean identities may not be in this form, right? They may have derived another formula. They may have solved for, sine squared instead of being solved as 1. So I want to go to, sorry, I'm going to leave these up for everything. I'm going to go to the first problem. And if you look here, we just need to verify that this is equal to this, okay? And so what I'm going to do is I'm going to take this side here, and I'm going to show why that both sides are the same. So I'm going to write it out. I have secant minus cosine equals sine times tangent. All right, and I have some subtraction here, and what I want to do is put my terms in my values here, my trig identities here in terms of sine and cosine, because that's going to help me out. So secant is 1 over cosine, and we're talking about theta, and then we're going to say it's minus cosine theta. Well, I can't put these together because they don't have like denominators. So what I'm going to do is I'm going to multiply this guy over here by some factor of 1 so that I have cosine in my denominator. So I'm going to multiply by cosine theta over cosine theta. And when I do this multiplication, and then I rewrite, I think I'm this color, that is going to be equal to 1 minus cosine squared theta all over cosine, right? Right? Because if you look at it, cosine times cosine is cosine squared. 1 times cosine is cosine. Right, so now I'm all set. Hey, look at this. Doesn't this look somewhat familiar? There's a cosine squared and a 1. Okay, well, this was just, sine squared plus cosine squared, right? But they just subtracted the cosine from each side, and it just became 1 minus cosine squared. So what does it equal? It equals what this is left over there, right? And so this is the same as sine squared theta is equal to 1 minus cosine squared. So this is also part of that identity, part of that Pythagorean identity, right? So what can I do? I can substitute sine squared for this cosine squared theta. So I put in sine squared theta over cosine theta. Well, if I look, I'm almost there, right? And what is tangent? It's one of those original guys, tangent. I always say it, tangent is equal to tan theta is equal to sine over cosine. And so I can break this up. It's sine squared times sine squared. Sine times sine is sine squared over cosine theta. And look, I have tangent here, I have sine here, and look, it equals the same thing. So it does equal sine times tangent. And so I'm going to get rid of this. And I'll get rid of this. And what I'll do is, since it's time for class soon, I'll do one more, and then I'll take a break, and I'll create the next problem. But I will do this problem, and then we'll move on. Okay, and so we have secant of theta is equal to sine theta times tangent plus cotangent. So this is the more complex side, so we're going to work on this one, and we're going to make it look like this. So I'm going to simplify this side, and I have sine, and I'm just going to leave that alone for a while because it's already in sine or cosine fashion. But I'm going to do tangent, which is sine over cosine. And I'm going to leave some room here because I have to do something with it. And then I have cotangent, which is obviously the reciprocal of tangent. So it's cosine over sine. All right, and I'm going to leave room there. And so I don't have like denominators, so I'm going to, again, multiply by that, that factor of 1 so that I can get like denominators. There's no sine over here, so I'm going to multiply by sine over sine. And I'll multiply over here by cosine over cosine. And when you do all this math, I'll give you the new results down here. We have sine theta still. And inside here, we have the same denominator. So I can just do that and say it's cosine times sine. I could have done it the other way around. Might have helped us, but we're all good. And then we'll have sine times sine is sine squared. Plus cosine squared theta. Well, if we look at our Pythagorean identities, sine squared plus cosine squared, look at that, in the right order and everything. What does that equal to? Well, we take this whole idea right here, I'll show you that these two things go together and they equal 1. So I'm going to rewrite the whole darn thing. I forget what color I was using. Hopefully it was this. And this equals sine of theta times 1 over, let's call it cosine times sine of theta. And I'm a little bit late, but I'm going to finish this up so that I can make sure you guys have your answers. This sine will cancel with this. And what do I have left? I have 1 over cosine of theta. And that's equal to, hey, look at that, it's the reciprocal. It's secant theta. All right, so that's how you do it. I'll try 2 more complex ones later, but these are the first 2, and I'll see you on the other side.